Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will provide information about the universal ports used on OWL optical power meters and will help clarify common misconceptions about the use of universal ports. Before we begin, however, it is helpful to understand the basic construction of a fiber optic connector. There are three main parts to a fiber optic connector: the connector housing, which defines the connector type, the strain relief boot, and the ferrule. It is the ferrule that is of greatest concern to the topic of universal ports. The main purpose of the ferrule, which is typically made from zirconium, is to protect the fragile optical fiber and to provide alignment when the connector is inserted into an optical port. Fiber optic connector ferrules typically come in two common diameters: 2.5 millimeter for ST, SC, and FC connectors, or 1.25 millimeter for LC, MU, and other small form factor connectors. Universal ports are designed so that only the ferrule is inserted into the optical port. Thus, all connectors that use a specific ferrule diameter can connect to the same universal port, regardless of their connector housing. This is what makes a universal port universal. For example, ST, SC, and FC all use a 2.5 millimeter ferrule and can thus all connect equally well to a 2.5 millimeter universal port. Likewise, LC, MU, and other connectors that use a 1.25 millimeter ferrule can connect to a 1.25 universal port. A common misconception about universal ports is that fixed ports have a latching mechanism and thus provide a better connection. This may be true for light sources, where core alignment in a light source port is critical for maximum coupling efficiency. For optical power meters, however, alignment is less of a concern due to the sheer size of internal photodetectors, which are typically a minimum of 1 millimeter squared. Compare this to the core diameter of an optical fiber. For example, a typical multimode fiber might have a 50 micron core, which is 1/20th the width of a 1 millimeter photodetector. Likewise, a 1 millimeter photodetector is over 111 times the diameter of a 9 micron single mode fiber core. Here's a useful illustration. Picture yourself pointing a flashlight at a wall from a couple feet away. It is obvious that the cone-shaped light coming from the flashlight will completely hit the wall, regardless of whether or not the flashlight is latched into place. In this analogy, the flashlight is the fiber core, the wall is the photodetector, and the light exiting the flashlight comes out as a cone, just like it does with an optical fiber. This illustration demonstrates that it is not necessary to have a latching connector to have the light source output fall completely on the detector. In fact, universal ports are more advantageous than fixed connector types, since universal ports offer the flexibility of connecting to multiple connector types. OWL's universal port system is designed to use threaded universal caps, one for each of the common ferrule sizes, covering nearly all of the common connector types in use today. To learn more about OWL's universal port system, contact the support department at OWL for more information. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more instructional videos, or to learn more about OWL's products in general, please visit owl-inc.com. I'm Professor Jim Powers. Thanks for watching.